Why did you want to be a cosmonaut?
Honestly speaking, I don't know. Really, I don't know. Because I was almost 5 then Yuri Gagarin flew. And I cannot remember this flu. But in half a year, in August of 1961, then German Titov flew. It was the second flight, a one-day flight on board Vostok 2. So I can remember this flight very well. And I was 5. And I can say that then I was 7 or 8. I have no doubts that I'll be a cosmonaut. So now I can say that maybe I was born with this wish. not wish, but maybe with this, yes, with this wish. So I don't know why. I don't know why. Maybe it was an influence of my father, maybe something else, but all my childhood was very close to the aviation issues, because my father, when he was young, he was a navigator, and he jumped with chutes, and he wasn't a pilot. Then he was a civilian engineer, but an excellent engineer, and I was amazed at how he solved different technical problems, from some homework to some inventions in his on his work. It was amazing for me, and it's an excellent example of an engineer. But then I finished high school. I decided, because before that I had two choices to be a cosmonaut, to be a military pilot or civilian engineer, because I saw that the Soviet cosmonauts were either from military pilots or from civilian engineers, and I guess that the civilian engineers, civilian cosmonauts, Soviet cosmonauts, were from special organization. And later I knew that it was a Korolev Design Bureau. Now it's called Energia. So I had a choice, and first I decided to be a military pilot, but later my father explained me that, and I understood by myself that it's more interesting and maybe more valuable to participate in designing and building spacecrafts and then fly, than to be only to fly with built by somebody planes. So I decided to be a civilian engineer in aerospace industry.
And you had that in mind when you went to university, yes?
Yes, of course. Yes, of course. At the end of high school, I looked through the list of institutes in the Soviet Union. It was a thick book, and I saw one institute in Moscow, Moscow Institute of Physics and Technology, and one of departments was called Department of Aerophysics and Space Research. And I thought, oh, it's for me, and it's for me. And now I can say that I was lucky to be in many times in my life. I was lucky to be at the right time in the right place. And that was the first example. That was the first time of this rule.
We have in English we say it's better to be lucky than good. So tell me about your career then. You went to this institute in Moscow, and tell me how that led you on into your place as a cosmonaut.
You see, it was very interesting, because then I entered the institute, and during the first month of studying, we we students were familiar with the system of education in this institute, and at the third stage of education, last stage of education, we had many activities in research centers, in industrial enterprises, with in areas of our specialities, and our group of students were tied to the Kaleri Design Bureau. So it's a fate. It's my fate. So after then I finished my school in the Kaleri Design Bureau. I had no doubts that I'll be working. I'd be working there. And after graduation, I entered to work in 1979 to the Design Bureau. It was called already Energia at that time, and from that time I am employer of Energia. Now it's a Rocket and Space Corporation, Energia.
And in that time you've been an engineer? And
yes, I was an engineer. Yes, I was an engineer, and maybe the previous selection of cosmonauts took place in 1978, and I entered in 1979. And then they started to select a new team in 1981. I was among the first persons. And in the 1984 I was selected, finally. I was selected, and now I'm a cosmonaut of Energia.
The part of your job that involves you flying in space is a part that we know has its possible dangers. You've experienced that yourself in your career. But Alexander, what is it that you feel that we human beings, what is it that we are learning? What do we get as a result of flying people in space that makes it worth taking that risk? How to explain the necessity of going behind the horizon. It's very human quality. So it's maybe most valuable frontier for humankind. Space flights and going into space and to the low Earth orbit and into the deep space. So I think I cannot say anymore. It's very, very valuable for humans, very valuable for humankind. But how to explain it? Why Magellan went around the world, around the Earth? Why? What kind of issue moved him? You're a member of the International Space Station's Expedition 25 and 26 crews. Alexander, can you summarize the overall goals of this 6-month flight and tell me what your main jobs will be?
The main goal is to keep the station in good shape and to maintain all the equipment working, and to perform a scientific program, a huge scientific program of all the international partners. But personally, I will be responsible about the Russian program, of course, and maybe some experiments in programs of different partners. Maybe I'm not sure about US, but definitely from European, not Japanese. So, and for me, personally, main task will be to test the upgraded Soyuz in flight. So for me, the most important and most valuable flight stages will be from the launch to the docking, from undocking to the landing. And on the station will be for me it will be ordinary stay with performing all the tasks. Very well known for me now.
Yes, well, you have, of course, done a tour of duty on the International Space Station before, as well as several visits to the Mir station. How do you compare a trip to this station as opposed to the Mir station?
It's interesting. So it differs in some details. You see, it's a new cooperation, new rules of operational rules, new flight rules, new relations between partners. So I think this is the most important and most remarkable differences between these two stations. Speaking in general. If say about my previous flight to ISS, then I think that this stage of station will be much more complicated and much more in the size. So now we will have at least 4 or 5 additional modules, and cupola. Cupola is a beautiful and wonderful eye to the Earth and into space. So I'm looking forward to have a look from this window to the Earth, to space. So I think, I guess it will be exciting sight.
You mentioned a moment ago that you are also flying to the station on a new edition of the Soyuz spacecraft. This has some upgrades from the Teyaman model that has been in use since 2002. Can you tell us a little bit about that? What is new about this Soyuz, and how do these changes improve its performance?
Mainly new changes took place in avionics, take place in avionics. So we'll have new computer system, onboard computer system, new onboard computer. We'll have a controlling and informational bus, joining different computers in the complex, onboard computer complex. So we'll have some more redundancies in this case. We'll have a new telemetry system. So it's mainly in avionics, and that is the new cosmonaut, new crew interfaces, like displays, like some information on displays, like some lights, some switches, and so it's an interesting version, and I think that the improving of Soyuz will get us new possibilities to improve it more and more, because the main issue is that now we'll have an open architecture of the computer system on board. Because on the TMA version, like in the elder versions, we had a closed architecture. Now we'll have an open architecture, and we can improve and improve it.
And continue to improve.
Yes, and continue to improve. Yes.
It must be a nice thing to have been selected to be the first to fly this new vehicle.
Yeah. Yes. I'm proud of it.
The Soyuz you will fly is different. The station that you will arrive to, as you mentioned, is different than the one that you visited on Expedition 8, and much different than the one that greeted Expedition 1 when they first arrived. And you shall be on board the station for the anniversary, the first 10 years of full-time human occupancy on board this space station. What do you think is the best thing that this partnership has done so far in these past 10 years?
I think the most important thing is that we work together and we learned how to work together in close partnerships and close cooperation. I think this is the most important thing. And what else? It's a huge station with a new architecture, with new possibilities. What else? And you see, it's very interesting because then I talked with Sergei Krikalev after his flight in Expedition 1. It was interesting because maybe half a year before I flew with Sergei Zalotin to Mir station. It was the last flight to Mir. And it was interesting because our flight was like a small model of the Expedition 1 on ISS. Because we had the same problems in activation of station, in configuring some system, in maintaining. So there were so close features, so close details in both different flights that it was amazing. And now I think that we made a new big step forward in the utilization of, not in the utilization of station, but in building, and now we are at the beginning of the real utilization of station, of ISS. And it's, I think it's the a new challenge for all the partnership to learn how to utilize the station in this cooperation. And I think that in next 10 years, what shall we? What can we wait from this? I think that we will perform new amazing experiments. Maybe for me, most valuable and most important is to perform experiments for improving human space flights. Maybe in techniques and methodology and aiming to the interplanetary flights. It's the most valuable for me. So it's my waitings for this 10 years period.
Let's talk a bit about the utilization that will happen now. There are, of course, a larger crew on board and many more laboratory facilities. So there are a lot of experiments, and a lot of them have to do with finding out how people will be able to live and work in the microgravity environment, which we will need for those longer explorations beyond Earth. Tell me about some of the different kinds of investigations during your increment that you will be involved with as the research subject.
As research subject, it will be mostly biomet experiments. So when my body will be under, and my brains will be under investigation. Honestly speaking, I don't like very much these experiments, but I understand that this is a necessity to go further and further in space flights. For example, our Russian researchers will investigate the mentality or the experiment so-called typology. They will investigate the possibilities of our brains to organize the mental process and to help in solving the problems in which is necessary to use either rational approach or emotional approach. So it's some kind of psychological experiment. We'll have some experiments in studying the cardiovascular system and some regulatory functions of cardiovascular and breathing and And we'll test new equipment for and new methodology for future experiments. You see, we'll have a new, maybe in 2 years, Russian segment will be fulfilled by, not fulfilled, but fulfilled by the new research module, big research module, MLM or MRM in English, and we'll have there a lot of scientific experiments, a lot of scientific equipment for different experiments in different areas, and we'll have a serious intentions to perform the biomet experiments of new generation using ultrasound and electrocardiography and in many different kinds of equipment. Nowadays equipment. So we'll have a lot of work.
You will have
as a subject.
Yes, and you will have a lot of work as the operators of experiments in other kinds of scientific disciplines. Tell me a little bit about the other sort of scientific research that you and your crewmates will be involved in.
You see, we have different areas in our in Russian scientific program. We have different areas of investigations: fundamental physics, geophysics research, astronomy, biology, medical experiments, some educational experiments. So about biomet, I've told already, and about we have a beautiful experiment, by my opinion, in fundamental physics called plasma crystal. It's a fundamental research, example of fundamental researches in physics. The specialists will investigate with our help the dust plasma in some conditions and ordered dust plasma in this environment. Applications, the field of applications of this knowledge will be huge, from maybe nanotechnologies to cosmology. You see, yes, they really have an applications and some ideas to apply this knowledge for forming of planetary systems, for planetary clouds. It's a cosmology. In some areas, in technologies, Earth technologies, with radioactive materials, so in atomic industry, and in some growing crystals, controlling growing of crystals. So it's a huge amount. I said, from nanotechnology to cosmology.
Along with the science research, there is, of course, regular maintenance that crew members on the station will do. And the current plan for your mission is calling for 3 spacewalks from the Russian section of the station in the latter part of the year. Tell me about who will be going outside on these EVAs and what work will be done.
You see, I am not too old to these EVAs, but I decided not to participate in these EVAs. I'll support it, but I decided that 2 EVAs will perform Fyodor Yurchikhin from Expedition 25 and Oleg Skripachka, and the third one, Oleg will perform with Dmitry Kondratiev from the next crew. But I'll be a supporter, but I am ready to do something extraordinary, if necessary. So I am ready for EVA, and I am ready to perform typical operations. But I am not involved in this these EVAs.
You have made a lot of EVAs of your own already.
Not many, not a lot of EVAs. I have only 5 EVAs. It's not so many, but each of these EVA was with some big peculiarities, and I can say that 3 of these EVAs I performed not being trained on the earth, on the ground, to these EVAs. So I had only onboard trainings and do them. So it's the most interesting for me. And all of these EVAs will be aimed to scientific purposes. It's for scientific purposes. To install a new working place for scientific equipment, to install some items of equipment, to reinstall, to demount, and to bring back in the, say, like expose it's the materials of European Space Agency, and maybe some biological objects exposed from the expedition 18. Then robotic, it's a European experiment for robotic arms and studying the qualities and ability to work in different modes for robotic joints, for some effectors, for some motors, and it's working maybe for 5 years already. So they are interested to take it, to bring it back, and to return to the Earth some of details of this equipment. We will install the equipment for laser communications by laser beams, and many other experiments.
The current plan for the sequence of events in your flight calls for shuttle Discovery to arrive at the station on mission STS-133 in November. Can you tell me just a little bit about what's on the agenda for when you get that shuttle visit near the end of the year?
I don't know exactly the flight plan and the cargo and the payload of this flight, but I'm looking forward to meet with Steve Lindsay, this crew commander, because we worked very tightly on the Earth, assigning crews and discussing the crew tasks in MCOP, so Multilateral Crew Operations Panel. And now we can meet on board the ISS. So for me, for both of us, it's very interesting and very exciting.
Well, we're looking at the at STS-133 bringing that permanent multi-purpose module and adding another room onto the station. And then early in the next year, STS-134 will come, and it will bring the alpha magnetic spectrometer. And at that point, you'll have the opportunity to see your commander, Scott Kelly, on orbit with his twin brother.
Yes, yes. And and I had many thoughts about how to distinguish them, how not to mix them.
STS-134.
Before closing the hatches.
The shuttle mission that Mark Kelly is commanding is the last scheduled flight of the space shuttle program, and so you will be on board to see that as well. What are your thoughts about the space shuttle's place in the history of human spaceflight and its role in building this space station?
It was a good and very interesting vehicle during the whole program. It's almost 30 years. And it was amazing program. And a huge amount of astronauts flew on board shuttle. So it seems me that at least 75 or 80% of American astronauts flew on board shuttle, and only maybe 20 or 25% of all because all the astronauts flew on different types, like Mercury, Gemini, Apollo. The contribution to the space program of the shuttle is huge, is amazing. And as to ISS, let's see, almost 1/3 of all the shuttle flights were performed for ISS. Beginning from STS-88, it was the first flight to ISS. Excluding maybe 2 or 3 flights, for Hubble servicing, it seems me 2 flights, and one was Columbia, unfortunately, Columbia STS-107. So almost 45 of 134, 1/3 exactly. So ISS cannot be built in this shape, in these forms, and these sizes without shuttle. So what can I say anymore?
Well, and
thank you, shuttle, for doing this.
When the shuttle is not flying, a major means of supplying the space station will be gone, but there are 3 other proven cargo ships that are flying to supply the station, and each of them is supposed to make at least one visit to the station during Expedition 26. Tell me briefly about the capabilities of these unpiloted Russian, European, and Japanese cargo ships.
Mm-hmm. Yeah, well, they are very different. Say, first, Progress and European ATV vehicle can dock directly to the station from the autonomous flight, and Japanese HTV can be docked only by a station manipulator. So it goes to the close vicinity of the station, then stays there, and then manipulator controlled by the operator from station captured it and dock to the docking port, special docking port. It's the first difference. Then I can say that they have different cargos, different possibilities to deliver cargos necessary to the station. HTV can deliver dry cargo, liquids, and cargos, not liquids, only dry cargos, mainly for Japanese modules. It's like logistic flights, but it can deliver the cargos both in pressurized volume or outside on the unpressurized platform. ATV cannot deliver unpressurized cargos outside the pressurized volume. Progress can deliver some special modifications of Progress, and we had this experience on Mir, on board Mir. Now it's not necessary for us, but we are ready. Russian side is ready to modify the Progress to deliver some unpressurized cargos. ATV and Progress are like in the big city, some cargo vehicles, or грузовики, cargo vehicles in the cities, trucks, big truck and small truck. You need both of them. So they are necessary both. But I can say that Progress can dock in any conditions, and it can be manually controlled by the crew. ATV cannot be controlled by the crew. So we are only monitoring the automated approach and final approach, and we can only stop it to be secure, to secure on the safe station, not more. So they are very different, but and they are very similar in their functions.
And you add to that the oncoming work that NASA is doing to try to bring in private cargo ships. So there are lots of different ways to bring supplies to the International Space Station in the future. I'd like to ask you to look beyond that into the further future and tell me where you think human spaceflight is headed in the next 20 or 50 years or so. And how is the International Space Station going to help prepare us for that future?
I hope that we will be aimed to the interplanetary flights, and the ISS or future space station will be a platform for doing some activities to get ready for these interplanetary flights. Testing equipment, methodology, some computer systems and so on, some software. And of course we'll work, I hope we'll work together in cooperation and international partnership. And what else? And we'll try new approaches to perform some maybe say already ordinary tasks like injecting to the low Earth orbit cargos by maybe private cargo ships like Dragon, like Cygnus, like some others. It's very interesting for me, and I think that this feature will be very interesting for our agencies to improve the economy of this activity.